Hello guys, we'll check the particles. Now, you know what is legacy. We'll go with the n particles. It is a fill object, but we'll go to the normal thing like a create emitter. Once you click it, you can see this emitter is up here, and also you can see that something is called a nucleus. Nucleus is nothing but a solver. Nucleus is a solver. It means no need to create the external field for the n particle. N particle always has a field is called a nucleus. In attributes of the nucleus, you can control things. Now the particles flowing towards down because of the attributes. Now you can see what the nucleus and check the nucleus attribute because the nucleus is a inbuilt field for n particle. You can see this gravity and gravity direction is -1. Suppose if you put 1, you can see it goes towards Earth. So it is by default is -1. So no need for the external fields like air, gravity, Newton, radiant, but this is useful for legacy particles. Okay, now we'll create a plane for the collision, but you cannot see it is colliding. See, it is true, penetrating through. So we need to change this as a passive collider. The passive collider is common for a cloth or an end particle or end cloth, anything. If it is a cloth, it will collide with this particular mesh. If it is an end particle, it will collide with a particular mesh. It is called passive collider. But the menu you can find out in an end cloth, not in an end particle. End cloth, create passive collider. Now, go back and play. Yes, it is colliding. Okay, you know what is collision means. Once you click the collision, it will ask you what is the bounciness and other thing. Correct. You can go to the attributes, then you can see and you can change what is the strength of the collision and then the bounciness. Bounciness is 0 for this one. Maybe I'll put little bit so that you come and bounce back. Go closer. Can you see this bounce, small bounce? Okay, now we'll increase more bounce. Okay, maybe I'll put 4 more. Maybe I'll change those. Planar. You can see the distance between the particles and then the object because of the thickness. You can see the thickness is a distance. Suppose if you put 0, it will exactly come and hit on the particles. Frictions goes. Stickiness will stick. You can see end rigid shape of this collision. So the particle is very simple that it will create the emitter will create the particles. This is the passive rigid body, passive collider, it will collide, and you can change the attributes. Now, sphere, I'm deleting the sphere because I want to fill the object. So something is called fill object particles. Then you can see fill object. What happened? Whatever the shape it's contained, the particle will get filled on this particular. Okay. But when you play, see it is going down. You know why? Because of the collision. Okay, we'll go to the cloth, passive collider. Now we'll play. You can see the particles goes down. Okay, this is the only difference between the legacy particles and end particle is self-collider, self-collision. Each and every particle will collide. How to do that? Just go to the attributes of this end particle and you can see the collision. Over there, you can find something called self-collide. Click on it and play again. Now we can see it is filled with a particle. It's not going down because of the self-collider. Now switch off the self-collider and play. Yeah, that's it. So there's a two types of collider. One is a mesh collider, it is called passive collider. Each and every particle will collide. That is called self-collision. Okay, now suppose if you're animating this, it's like pouring. Let's check. That's it. Nice, isn't it? In this collision, you can decrease the collision strength, so the attraction will become more less. What is the particle size and increase the radius of the particle size, so the collision will overflow. See, because each and every particle size is different now. Now, 0.2, you can see the size of the collision is less. So this is the particle size. Lifetime, you already know that. Life forever or constant. Okay, collision layer is fine, the scale is fine too. And how much bounciness we need, friction we need, and then stickiness we need. Stickiness is for the viscosity, increasing the stickiness. Now play. I'm sorry, it is taking some time to catch the memory. Sometimes it is stuck. So try to minimize the particle count. Otherwise, yes, it'll hang your laptop. Okay. Now we can see the dynamic properties of this one. Local force. Which axis we need a local force? X, Y, Z. Okay, one is the local force. Now we play. Now you can see this. The force of the Z axis is more. Dynamic weight is fine. Same way the wind, drag, dump, and mass. Mass is a weight. If you increase the more mass, it will fall quicker. Drag, dump. Okay, increase the dump. See? Dump now. So mostly it should be 0 to act properly. This is called a fill object. Okay, what is goal? Goal, okay, select the particle. Okay, I'm creating another sphere here. Select the particle, shift select this shape, n particle goal. When you play, it will go and stick with the goal object. Okay, now I'll show you. Okay. But even the goal object is hidden, it doesn't matter. You'll go and stick with the particular shape. Let me play again. Got it? Suppose if you are moving the sphere or deforming the sphere, the particles also will get deformed. It is useful for many purpose. Okay, I go to the window, general editor, content browser, taking some shapes, maybe a face, decrease the size of the face. Now I'm using the create emitter. Select the particles, shift select the mesh. They are going to do the same thing. Goal. what happened? This particular particle will go and fix with the phase according to the particle count. It will take a much time. Maybe I can go for 500 frames. And also you can hide the character. Now you can see slowly it is building the character. In the Mummy Returns, Mummy movies, you can see the particles will create the shape. Then the mouth will open like something like that, isn't it? So it is a particles. It's uh, go and go with the particular selected. Suppose the particular selection is moving or shaking the head, the particle also will do the same thing. Sandman, in Spider-Man, you can see the Sandman. It's the same concept. But here we are playing with the thousands of particles. Over there, we are going to play with the millions and billions of particles to get the realistic effect. But here you can practice it very small scale. If you got the good missions, yeah, we can achieve that particular effect. So this is for these particles. Whatever you select, it will go and shape the particular. Yeah, if the mesh is moving, deforming, of course the particle will do. Okay, anytime you can change the instance. It means you can change the goal value. Okay. Now we can go to the next. You can see this particle, how beautifully it is. Yeah, it will go and stick with the vertices. Exactly. If you need a more dense, you need to smooth your mesh. And then also the particles can be multi-particles. Okay, how to make this as a shape? We'll do the next one. It's called Instencer. Now, creating the mid from object, no. First we create the particle tool, clicking the particles. Okay, I'll do it again. Oops. No, let's go to the create particle tool and particle from here to here to here. We got a particles. Now select the object which you want to instance. Replace the particle. Select the instance object, shift select the particle. We can just click in particle, instance. All the particles become this shape. Okay. Any object, suppose if it is moving, of course, your instance also will move. If you walk a character and you create the particles and you do the instance, of course, all the particles instance will get moved. So that is called instance. Suppose if you make a goal object, you can do the instance. Okay, so you can try with the instancer, goal, and fill object, and try to do some attributes adjustment of the end particle, nucleus, and rigid body. Okay, guys, that's it today's section.